Okay, we're going to take a look at a couple of problems, 19, 20, and 24A, so that you can complete the homework assignment for Tuesday. We are looking at focusing on polynomial functions and models and how those polynomials behave, their end behavior. Remember, if it is an even power, it's positive, both hands go up. If it is an even power negative, both hands go down. If it is an odd power and it's positive, one hand goes up, one hand goes down. Remember, it increases from left to right. If it is odd power and it is negative, it decreases from left to right. So let's take a look at problem number 19. It says for the polynomial function f of x is equal to that 3 times the quantity x plus 1 squared times x minus 3 squared times x squared plus 2. Complete the following without the use of your calculator. So list each real zero, x-intercept, and its multiplicity. So when we look at x plus 1, we know we have a 0 at x is equal to negative 1. That has a multiplicity of 2. Then we look at x minus 3, so that tells us we have an x-intercept at 3, has a multiplicity of 1. And the last one, x squared plus 2. If you solve that, you're going to find that that's not a real number solution, so we don't have to worry about that one. We only have 2 intercepts. One at negative 1 and one at 3. So we know when it has a multiplicity of 2, it's actually going to bounce or touch. And when it has a multiplicity of 1, which is odd, it's going to cross. So we know it's going to cross at 3. It's going to touch at negative 1. Let's look at where the y-intercept is. So if you let x equal 0, you will have 3 times 1 times negative 3 times 2. Just going to put that y-intercept at 0, negative 18. So it's going to be down here somewhere. So that will tell you that your function is going to come up, touch the x-axis at negative 1, come down, cross the y-axis, and then go back up, crossing at 3. It says find the power function that the graph resembles for large values of x and determine the end behavior. So that's going to be y is equal to a, where a is positive, sub n, x to the 5th power. This is a 5th degree polynomial, so it's going to look like that odd power model. It says determine the maximum number of turning points. Maximum number, remember, is n minus 1. Here n is 5, so 5 minus 1. Maximum number of turning points here will be 4. Okay, let's take a look at number 20. This is the same type of problem. We're looking at the x-intercepts, looking at the end behavior, and where it touches and crosses. So the first one, I have an x-intercept at x is equal to minus 1/2. That's an even power, so I know it touches the x-axis at minus 1/2. Then I have x plus 4, so that tells me I have an x-intercept at minus 4. It's raised to an odd power, which tells me that it crosses the x-axis at negative 4. Substituting in a 0, I'm going to get a y-intercept of 0 times negative 32. So when I go to graph this, I know it's negative and it's raised to an odd power. The degree is 5. You're going to add those together. It's negative, so the end behavior is quadrant 2 and quadrant 4. I know at x equals minus 1/2, it touches and it crosses at 4. I know I have a y-intercept here at negative 32. Oh, negative 4. I'm sorry. 1, 2, 3, 4. So it's here at negative 4, not positive 4. So I know it crosses, so it's going to come out of quadrant 2, down into quadrant 3, come back up, touch at minus 1/2, come back down and cross the y-axis at negative 32. And so it ends, end behavior is in quadrant 1 and quadrant 2. Again, find the power function that the graph resembles. Y is equal to, this time, negative a to the 5th, x to the 5th. Determine the maximum number of turns, n minus 1. So that's going to be 5 minus 1, which is 4. Okay, let's take a look now at question 24a so that you can understand how to do 24b and c. First thing you want to do is identify your x-intercept. So I have x is equal to negative 3, x is equal to negative 1, and x is equal to 2. And I'm asked to write a polynomial function given this information. So that tells me that the terms of my polynomial will be x plus 3, x plus 1, and x minus 2. Now look at the multiplicity on each. X plus 1 crosses, so it's raised to an odd power. X plus 1 also crosses an odd power. And then at x minus 2, it touches, so it must have an even power. Let's see, it says find those. You know you have a y-intercept at 0, 6. So let's take a look at what this function will look like. I have f of x is equal to a times x plus 3 to the first power, x plus 1 to the second power, and x minus 2 squared. So that, and when I look at this, I have end behavior in quadrants 1 and quadrants 2. So I know it has to be raised to an even power. I have to find then the value of a. I have this y-intercept, so I'll substitute that value in. 6 is equal to a times 0 plus 3, 0 plus 1, and 0 minus 2 squared. That's going to give me a value of a that is 12. So 6 is equal to 12a. So a is equal to 1/2. So the polynomial function I'm looking for is f of x is equal to 1/2, excuse me, 1/2 x plus 3 times x plus 1 times x minus 2 squared. So the steps here are to look at the end behavior of the function and understand if you're first dealing with an even or an odd degree. Then to look at the intercepts to determine your factors. Then find your y-intercept to determine your value of a, and then establish that polynomial. Okay? That's it for this video. Have a nice weekend, and I will see you Tuesday.